An algorithm is a recipe for solving a problem or completing a task. Imagine it like a step-by-step cooking instruction to bake a cake. Just like the recipe tells you what ingredients to use and the order to mix them, an algorithm tells a computer what specific steps to follow to achieve a desired outcome. These steps can be anything from simple calculations to complex decision-making processes. So, the next time you see a cool video effect or hear a song recommendation online, remember, there's probably an algorithm working behind the scenes. Properties of an algorithm. Algorithms are the secret sauce behind the magic of technology. They're like step-by-step instructions that tell computers how to solve problems or complete tasks. But for an algorithm to be truly effective, it needs to follow some key principles. Let's explore these properties in detail, using real-life examples to bring them to life. 1. Input. Clear instructions. Imagine a recipe without ingredients. An algorithm needs well-defined input, like numbers, text, or even data from sensors. This input acts as the raw material the algorithm works with. Example: sorting a list of names alphabetically. The input could be a list of names as text strings. 2. Output. Delivering the goods. Just like a recipe tells you what delicious dish you'll end up with, an algorithm should have a clear and specific output. This is the answer or solution the algorithm produces after processing the input. Example: sorting the list of names alphabetically. The output would be a new list with the names arranged in alphabetical order, A to Z. 3. Finiteness. A clear endpoint. Have you ever encountered an endless recipe? An algorithm shouldn't keep running forever. It must have a finite number of steps that lead to an eventual termination point. Example: imagine a maze-solving algorithm. It wouldn't be helpful if it kept exploring the maze infinitely. The algorithm should have a defined set of steps to find the exit and stop when it reaches the goal. 4. Definiteness. Unambiguous steps. Think about a recipe with vague instructions like, add a pinch of spice. An algorithm's steps need to be clear, precise, and leave no room for misinterpretation. Each step should be definite so the computer can follow it exactly. Example: a recipe for chocolate chip cookies might call for 1 cup of flour. An algorithm translating this recipe into computer instructions would need a specific measurement unit, e.g., grams, and avoid ambiguous terms like a pinch. 5. Effectiveness. Every step counts. Imagine a recipe with unnecessary steps that don't contribute to the final dish. An algorithm should be efficient, meaning each step must be relevant and contribute to achieving the desired outcome. Unnecessary calculations or redundant steps should be avoided. Example: an algorithm searching a phone book for a name wouldn't need to start at the very beginning and check every single entry. It could use a more efficient search method to locate the target name much faster. 6. Efficiency. Speed and resource management. While effectiveness ensures all steps are relevant, efficiency focuses on how quickly the algorithm achieves the result. It considers factors like the number of steps involved, memory usage, and processing time. Ideally, an algorithm should solve the problem in a reasonable amount of time and with minimal resources. Example: imagine 2 sorting algorithms, one that compares each pair of names in the list and another that uses a more efficient divide and conquer approach. The second algorithm would be faster and more efficient for a large list of names. By following these properties, algorithms become powerful tools for computers to solve complex problems and automate tasks. They ensure clarity, efficiency, and reliable results, forming the backbone of the digital world around us.